What's up, Algebra 1? We've been talking about arithmetic and geometric sequences, and so at this point, really hoping we've got a lot of skill in identifying which one's arithmetic, which one's geometric, along with if it's arithmetic, what would that common difference be, or if it was geometric, what's that common ratio. And so I wasn't able to do this completely on the board at school, so I just went ahead and scribbled some down on some of these questions, and I'll just kind of talk you through a few of them and just kind of support you. Let's jump into it. So number one, we want to kind of analyze -2, -4, -8, -16. And the problem is that if you subtract -4 and -2, this is how you learn that it's subtracting 2. So -2 minus 2, that's giving you -4. If it's arithmetic, though, you should be able to subtract 2 again and get -8. But the problem is that that's really giving you -6. So I want to abandon the thought that it's geometric and try dividing the second number and the first number. And this tells me that if I'm using multiplication, you're multiplying by +2. So for example, -2 times 2, that would be -4. Multiply that by 2, you're getting -8. And multiply that by 2, you're getting -16. So these are staying negative, meaning you're not multiplying by a negative, you're multiplying by a positive. However, you started with a negative. So -2 times +2, still -4. -4 times 2, still negative, but it's -8. So I really want to challenge you guys to memorize these formulas. A1 multiply R n minus 1 for the power. You've got to know these formulas, or at least the models, so that when you are plugging in the first number or the common ratio, or for the next one we're going to talk about the common difference, you must know the starting formula for each one. So for example, with this one, you are starting at 65. 65 is your first number, and so this number we are treating as our A1 value. And now we start thinking about the common difference. And so I'm going to bring up a calculator and take that second number and subtract the first number. 60 is the second number, minus 65, the first number. And you get -5. And that's because it's decreasing. You're subtracting 5 over and over and over to get the next number. And so it's very important that I treat this number as a negative. I know it's a plus in the formula, but that's just to say basically the sign of the common difference controls whether this is a plus or a minus sign. So because that's negative, I need to multiply -5 times n, -5n, but this is where I'm seeing a lot of mistakes. Oh, that's not a good color. -5 multiply -1. Negative times a negative, +5. So I'm seeing a lot of mistakes with that. And one thing that I've tried to teach over time is a way of kind of catching yourself is you should really check your equation. So for example, I have -5n plus 70, -5n. I'm going to try to see if I get the first number out, plus 70. And so when I plug in 1, I do in fact get 65. And if you were to plug in, let's be crazy, let's plug in 4. Well, 4 should be the fourth number in the sequence. So it says it should be 50. 1, 2, 3, 4. See, 50 is in fact the fourth number. So my formula is working well. And something else that I've been slowly showing those that are ready for it, because, one thing at a time when you're learning this stuff, this 70 value should be the value that would have been in front of 65. So for example, if we were to go back in time to figure out, okay, it was going down 5, well, what number would have theoretically been right here? Well, that number would have been 70. So that's another way to kind of quickly know whether you're doing it right or not. These details are more advanced and they take more practice and more thought and more meditation before you use them on a consistent basis. So let's try a few more. This next one, 5, 13, 18, 23. If you see that the numbers seem fairly similar, that should kind of key you in on arithmetic. And when I say similar, like those numbers are staying relatively close together. Like 8 and 28 aren't really that far apart for them to be like 4 or 5 numbers later. Let me see if I can find another one here. Like, for example, this one is definitely geometric. See how fast that got to 675, starting at something as low as 25? So there's some kind of smaller details that kind of help you figure out what's going on. But in general, I'm going to give my approach here of how I determine what's going on. So let's kind of jump into explaining this a little bit. When I look at a sequence, the first thing I always do is mentally subtract these two numbers. And if I need to use a calculator, I will, but 13 minus 8 is positive 5. I'm now going to check, like, well, if that continues, like 13 plus 5, okay, you get 18, and 18 plus 5, that's 23, and 23 plus 5, okay, this is perfectly linear, or perfectly arithmetic, if you will, because you continue to have a common difference between each value, which is positive 5. So that should be a part of your answer, and I'm, again, just revealing these things slowly, but this 5 right here, 5n, like 5 times 1, 5, 5 times 2, 10, that has a distance of 5 because they're in multiples of 5, and so you really need that 5 as a coefficient of n, and that controls its, adding 5, or if it's negative, subtracting. Now, once we go through the process here, 5 times n, 5 times negative 1, we get 8 minus 5, which is positive 3. I know sometimes in math, when we're solving equations, we'll change those signs, like, oh, the opposite of adding is subtracting and all that, but that's only when you're solving an equation. There is no equal sign between these two values, so that's the only time you should be doing things like that. All right, number 4, the first thing I'm going to do is subtract these numbers mentally, or if you want to use a calculator, you are welcome to do so. And I know you may not all have a graphing calculator, but everybody needs to have some calculator outside of class that you use for your homework. So 1.5 minus 1, it looks like I'm adding 0.5. But again, if you try it, 1.5 plus another 0.5, see, that would not be the next number in this sequence. So again, it fails the arithmetic very quickly. And now you are thinking geometric, especially when the directions limit you to it being either arithmetic or geometric. It's not both or neither. So the next thing we want to kind of jump into is this model that I hope we are memorizing, being very transparent about that. Hopefully A1 is your first number, and then you're multiplying by your common ratio. Sorry, I want this to be in the general form. I hate when I have to write with the mouse pad. It makes it really sloppy and hard to read. So anyway, we abandoned the arithmetic model, and now I'm wanting to divide these numbers. So I'll do the second number divided by the first number. And if you've got good mental math, dividing by 1 doesn't really change the value. So that means I'm multiplying by 1.5. For example, the first number is 1. I'm multiplying by 1.5. A little bit of lag because it's filming the video, and that gives me 1.5. Well, then multiply that by 1.5, and you get the next number. Multiply that by 1.5, and then you continue to get the values out that are in the sequence. And so 1.5 is the same as what I am using, which is 3/2. Math enter, and the graphing calculator will change any decimal to a fraction. And so I've got my 3/2, that's my R value, and then my n1 minus 1 power. And you may be thinking, well, why don't I write 1 here? Well, when 1 is the first number, it's really understood. It's kind of like if I say, well, how many y's do you say? You'd say 1, and I'd say you're right, there's 1 y. So you want to get used to not seeing that value there, especially for like multiple choice. SAT, ACT stuff. You want to be prepared for that. So I'm going to let you try 6 on your own. I've got 5 here though. If you take 3 and subtract 5, you get -2. And that continues to be correct. 3 minus 2 is 1. 1 minus 2 is -1. And so again, I am doing that model. The first number is 5. You are subtracting 2 over and over. And I know I'm putting plus D, but that's just the formula, the common difference value, which is -2. And then n minus 1 is just part of the formula. And so we're going to distribute. We're going to combine like terms. And you always want to just mentally check, like, does this actually work? If I start plugging in values, -2 multiply 1 would be -2 plus 7, 5. You do, in fact, get the first number out when you plug in 1. So now let's plug in 2. -2 times 2 would be -4. -4 plus 7 is, in fact, 3. And just to really guarantee that everybody sees what I'm talking about with a calculator, let's plug in 3 using the calculator. So again, the formula is -2n plus 7. Really going to stress this as much as possible. I think this is kind of the foundational concept of using the formula to model a sequence or to find future values. So this was -2n plus 7. That is the exact formula that I have. However, n is replaced with 3. I'm trying to see if that is in fact the third number in the sequence, which is 1. So everything is working perfectly fine. So I'm really kind of just trying to teach this over and over. Input gives you the position. Number 7. Let me find my eraser here. Everything's so easy when I have my smartboard, but I don't have my smartboard. So 25, 75, 125. If you take the second number, divide the first number using any calculator or mentally do it, whatever you want to do, 75 divided by 25 is 3. So you are starting at 25 and you are multiplying by 3. 75 times 3, 225. 225 times 3, 675. And so I want to use that model again. The first number is 25. You're multiplying by 3. N minus 1 is the power. And anytime you need to know the R value, divide the second number and the first number. All right. Number 9, another geometric one that I wanted to do. Students really struggle when it feels like division. All right, so a little something that you need to know. The division symbol is a fraction. And you can even see it. Here's your dividing line. Here's your numerator value of 1. You are dividing by the number 2. So those 2 points just represent like possible values you could be dividing. But you really need to think of it as a fraction that you would use with multiplication. And there's a lot of combining operations where it's like, is it multiplication? Is it division? Yes. It depends on the values itself. But I will demonstrate. If you are thinking 320 divided by 2. Yes, that is 160. But 320, sorry, times 1/2, 1 over 2. That is the exact same thing as dividing by 2. And it has to do with you're multiplying by 1, so the number's not changing, but then you're dividing because 2 is in the denominator. So we must think of it as a fraction value. Okay, so there's your first number, there's your A1, again there's your model A1, and then you have to figure out the R value, which is what I've been talking about. If you divide these 2 numbers at first, 160 divided by 320, you will see that that is math enter 0.5 or 1/2. Cool. All right, so getting to the very last problem. A lot of times the way that you get paid is in sequence concepts. So you get paid in a very linear way a lot of times because you get paid per hour, and you may have even had some starting amount that you already had in the bank, or maybe you get a bonus for starting. But in general, you are trying to solve for how many hours she needs to work if she gets a bonus of $50 and then she's working $9.45 each hour. How many hours does she have to work in order to make $135.05? So I will check your work tomorrow in class, collect it, take any questions, email me if you have any questions. But we're going to have a quiz on Friday. See ya!